Okay, here we are with our last set of notes for week 4. We want to now go backwards. Last video we were multiplying special products, and now we're going to factor special products. We're going to do a little bit of extension. You do already know how to do this. We're going to find zeros, and we're going to graph the special products as well. So we have perfect squares. I just want to make the list of perfect squares for you again. And refer back now to our special products from last video. What we notice is that we have a squared value and that 9 is a perfect square. So that means this is a special products trinomial. And what we're going to do is we're going to do x, and we're going to do, now what's the square root of 9? Right, so it's going to be 3. And we're going to have a minus plus scenario. Okay, cool. Now what we want to do is try multiplying it back together. Does it produce x squared minus 9? X times x, x squared. X times 3, 3x. Negative 3 times x. Negative 3 times 9. These dudes in the middle cancel out. There you go. So yes, this does work. So if we square root the first number and we square root the number on the end, that's how we're going to factor our special product trinomials. Let's go ahead and skip over to this one. Is the first value squared? Is 121 a perfect square? Then I will factor this like it's a special trinomial. I factor x and x. What is the square root of 121? What is the square root of 121? It's 11. And it's going to be a minus plus. The minus plus tells us that the middle value of the trinomial cancels out. Cool. Let's look at this different scenario where we have a number at the end. We have a c value, a constant at the end, but we also have our good old b value. Is x squared a perfect square? Yes, it is. Is 4 a perfect square? Yes, it is. Is this middle value 2 times the square root of 4? Yes, it is. So we're going to do x plus and x plus. Now what is the square root of 4? 2 and 2. Cool. And again, we can multiply it. We would get x squared plus 2x plus 2x plus 4, which would be x squared plus 4x plus 4. So going forward and backward, this does work. Let's skip over to the question on the end. Is the first value a perfect square? Yes, it is. Is the value on the end a perfect square? Yep, there it is right there. So the square root of x squared is x. It's going to be plus plus. What's the square root of 144? Nice. Good job. So what we want to do with this is we want to be able to factor it and graph it. So let's be able to move beyond just the basics and say, okay, I can get this far and I can now graph it so I can see what it looks like. So when I'm going to factor my special product, I'm going to have x. What's the square root of 9? Very good. And because there is no b value, no value in the middle, it's going to be minus plus. To find our zeros, we have to set our factors equal to 0 and solve them. So I would add 3 and I would subtract 3. So x is going to be 3, x is going to be negative 3. Do you remember what the y-intercept is? It's one of those numbers in your binomial. Do you remember what it is? Right, it's the 9. Oh, wait, is it 9 or negative 9? Very good, it is negative 9. So we have zeros at 3 and negative 3, and that's going to be on the x-axis. And we have an intercept that's negative 9 on the y-axis. Okay, so I'm going to draw a nice little coordinate plane here. Actually doesn't need to be that big. So I'm going to have positive 3, I'm going to have negative 3, and then I'm going to go up to, oh, I need to go down. So I redrew my graph so that I have positive 3, I have negative 3, and I have negative 9. Now I want to connect my dots with a nice smooth curve. Easy peasy, just like that. Cool, good job. Pause the video, do the problem on the right, and come back and check your work. So I color-coded for you. You can see where I got the 11 from. It's the square root of 121. You see where I got the negative 121 from. It's the constant that's at the end of our quadratic. And then you can see where I graphed everything. You'll notice this time I did not count to 121. Instead, when your numbers get really big, as long as you label them and try and make it look proportional, your graph will be acceptable. So like I'm looking down right underneath that 121 and I see a 144. I know I'm not going to count up to 144. That would be gross. All right. So now let's look at the other special product that we had. We have a perfect square. We have a perfect square, and we have 2 times some number. So if I have a perfect square in the beginning, a perfect square at the end, and a even number in the middle, this will probably be a special product. So as we factor it, we're going to do x and x. The square root of 4 is 2. And since all the signs are positive, these will also be positive. We do the same thing where we get our zeros. I'm going to subtract 2 from both sides, and I'm going to get x equals negative 2 and x equals negative. Ooh, that's interesting. That's interesting that both of my zeros are the same. Wonder if that's going to happen every time. Well, does that make sense that it would happen that since my factors are the same, my zeros will be the same? Neat. What's the y-intercept this time? It's positive 4. Very good. Now we're going to graph this. This is going to look a little bit different. So we're going to go here, and you're going to notice we're going to aim to have more of an upper part of the graph than the bottom part. We need a y-intercept at 4. So there's my y-intercept at 4. I need an x at negative 2. There's no other x value. So if there's no other x value, we're going to do something called bounce. Because I have a multiplicity of 2, you'll learn that next year in Algebra 2. Because I have a multiplicity of 2, an even number, I will bounce off the x-axis instead of go through it. So I'm going to come down and bounce and then go back up. Is that always going to happen with this kind of special product? Yep, it surely is. So we had a perfect square at the beginning, we had a perfect square at the end, we factored, we found our zeros, and we noticed that the zeros are the same. And because the zeros are the same, we're going to bounce. Go ahead and try the next problem, and then come back and get the answer. Okay, check your work against my work. Did you find the square root of 144 was 12? Did you solve for x and get negative 12? Did you get the intercept at 144? What I did this time is I zoomed way in and I made every hash equal to 12. So I tried to maintain the same scale on both the x and the y intercept. Again, you don't have to. As long as you're labeling everything, you'll be fine. Cool. So what you're going to do is you're going to try these two here at the bottom. Submit your notes to me. And please remember, if you're struggling at all, would you please come join me at WebEx? I would love to see you, even if you just want to hang out for a little bit. Good job today.